Good afternoon. My name is Nicholas Spalding. I'm the SI leader for Math 1121, and today we'll be reviewing Section 6.2, Areas by Integration. I will start with going over the lecture notes from class that are up on the screen, starting with the examples 2A, B, okay. Example 2A reads, find the area bounded by the curves. I will also go over homework 6.2, a couple problems for homework 6.2 and homework 10.1. Example 2A from lecture notes. Find the area bounded by the curves y equals 3 over x squared and y equals x minus 3 between x equals 1 and x equals 2. I'll grab my calculator. First, we'll start out by graphing the two functions. Y equals 3 divided by x squared and y equals x minus 3. Graph. Mine is in a funny mode. Okay, I have a graph. So I'm going to draw this. X-axis, Y-axis. Matter of fact, yeah. We have the points x equals 1 and x equals 2. So we want to find the area. We want to find the area under the curves, the two functions between these 2 points. There's 1 and there's 2. This is y equals x minus 3. And this one is y equals 3 over x squared. We are looking for this is x equals 1, x equals 2. and we want the area bounded by these curves. So we'll use integration. And you're always going to subtract the upper, which is right here, minus the lower. So area equals integration of upper limit, lower limit, upper function minus the lower function. Dx. In respect to dx, which is the change in x across the x-axis. Okay, we're going to solve this. But first we need to do that, we need to take the antiderivative of each term. I'm going to simplify this by writing it as 3x to the negative 2 minus x minus 3. They give us, I'm going to take the antiderivative of the first term. I'm going to do it on the side. They give you n minus 1 equals negative 2. Which means, I think he did this in the lecture notes. No. They give you n minus 1, which means n equals, let me get the form. I'm getting my form right. Okay, we're going to use this formula for antiderivatives. They give you n minus 1, which means n equals negative 2 plus 1, which is negative 1. What else? So this is u. You're looking for k. U equals x. So let's write it. K negative 1 x n minus 1 is negative 2. Or u plus n. That's this form. We wanted to make it the other form. No, that equals, this form equals the function. x to the negative squared. So kn, forgot n, kn u n minus 1 equals the function. These cancel. Negative 1, k equals 1, k equals negative 1. So rewrite it as negative 1 x to the n is negative 1. Or negative 1 over x is the antiderivative of this. So once you get the antiderivative of both, antiderivative of this is should be able to do it in my head. N plus 1 over, let's do it. U equals x. N minus 1 equals 1. N equals 0. U plus 1 equals 1. So x is 1 over 1. Which is x. N plus 1 over 1. N plus 1. Which doesn't come out right. It's got to be 2x. Is 1. All the way. N minus 1 equals 1. N equals 0. Kn, that's not going to work. One plus 1 is 2. That's why. N plus 1 equals 3. X to the 3 over 3, 1/3 x to the third is the antiderivative minus 3x. Minus 3x. Upper limit, lower limit. Okay, we have integration and antiderivative form. I'm going to erase the antiderivative work I did to make room. And after this, it is only plug and chug from there. So once you get this, the antiderivative of the two functions, all you want to do is plug the upper limit minus the lower limit, f b minus f a, which is f of 2 minus f of a. 1. And that and all that's doing is plugging 2 into the function where the x's are minus 1 where the x's are. And you can easily do that with your calculator. Y equals, type in your antiderivative right here. Negative 1 divided by x minus 1 over 3 1 over 3 x to the cube minus 3x negative 1 over x minus 1 over 3x cubed minus 3x. Graph it. Error. That's our antiderivative. Second calc value. You can easily find that f of b, which is 2. So f of 2 equals 2.8333. F of 1 equals 1.67. F of b minus f of a is 2.833 minus 1.67 equals 1.163 is the area in units squared. This is our summation of the areas. It's vertical, which is why we kept our function as y equals f of x. When it's horizontal, say the upper and lower does it remain upper and lower? Then you have to try the horizontal. In that case, you have to get x with respect to y, which is if you had y equals x, or square root of x, take the square of both sides, it'd be x equals y squared is the function. So 1.163 units squared is the area under the curve. Okay, I'm gonna try, next I will try another vertical problem like this one, a horizontal problem, and one more from the lecture notes. Okay. So next problem I will do is from the homework. It's homework 6.2, number 1, and that's another vertical problem, very similar to this one. Problem number 1 from homework from section 6.2 reads, section 6.2, number 1, y equals 4x, y equals 0, x equals 1. First graph the function. Y equals 4x. Graph. Straight line. Similar to that. Y equals 0 is the x-axis. X equals 1 is right here. And we want the area. Find the area bounded by the indicated curves. The area between y equals 0 and that function is right here. That's the area we're trying to figure out. From the y-axis to x equals 1, the upper function stays the upper function and the lower function remains the lower function. So we can use the vertical line, vertical summations of those areas to get that area. So we would write the equation for the area, which says area equals integration of the upper limit, which is 1, lower limit 0, the y-axis, upper function minus the lower function, which is, upper function is 4x minus the lower function, which is 0. 0. Well, you don't even have to put nothing. And from here, it's just an integration problem. You need to find the antiderivative here, then plug in f of b minus f of a, and that gives you your area in units squared. So the antiderivative of 4x would be, take the 4 out, n equals 1, no, n minus 1 equals 1, n equals 1 plus 1 is 2. U equals x. So u to the n plus 1 over n plus 1 is the antiderivative. U is x to the n plus 1. N is 2, n plus 1 is 3. So 3 over 3 is the antiderivative. You have a constant of 4 here. I think I forgot to bring that constant back in on the last problem. But it'd be 4 upper limit, lower limit. I'm going to take this derivative. I'm going to take the antiderivative of this just to make sure that our answer is right. So it's 1/3 3 times x squared, x squared. So that might not be the right answer. It's okay. So u equals x, n equals 1, n plus 1 equals 2. U to the n plus 1 over n plus 1. They give you n in this case. In the case where we use this, they give you n minus 1. Okay, so that will make this x squared over 2. Cancel 2x squared. F of b, which is the upper limit, minus f of a, the lower limit, equals the area. We have a function right here. Our derivative is 2x squared. I don't want to graph both of them, just the antiderivative. Plug f of b, which is the upper limit, which is 1, minus f of 0 equals the area. So 1, it gives you 2 minus, plug 0 in, and you get 0. Area equals 2 units squared. Okay, that completes this one. Next, I will do a horizontal. I will do one. Excuse me. I will do one where the upper limit does not remain the upper limit. It might change to the lower limit. In that case, you have to do a horizontal integration. And this is number 11, section 6.2, exercises number 11. And it reads, y equals 4 minus 2x at y equals 0 and x equals 0. First, graph the function y equals 4 minus 2x. Graph. Straight line. Something like that. Y equals 0 is the x-axis. X equals 0 is the y-axis. So you want the area bound in here. Y equals 0. X equals 0. This is x equals 0, y equals 0, in this function. Is that number 11? Wrong problem, that's why. That's the vertical problem. I'm trying to do a horizontal problem. Excuse me. I'm trying to do a horizontal problem. Excuse me. A horizontal problem is number 11, and it says y equals square root of x. X equals 0. Y equals 1. Y equals 3. Make sure I write that down right. Y equals 3. Graph it. Square root of x. Graph. X-axis, y-axis. Function. Y equals square root of x. X equals 0 is the y-axis. Y equals 1 is right here. Y equals 3 is right here. Whereas y equals 3 You see how this draw is not the scale. So the problem I'm having is that I didn't draw the curve in between those boundaries. So I'm gonna find out where this is y equals 3, this is y equals 1. I'm gonna find out where x equals 3. Now I need to find out where y, excuse me. Okay, that's fine. Grab a table. So at 1, I don't get to 3. My function does not get to 3 until x is 9. So somewhere down here. Okay. And I'm looking for a boundary between that function, this is my boundary. X equals 0 is the y-axis. Y equals 1. And y equals 3. So this is the area I'm looking for. Equals 1. This is the upper function. For this one, we will do the horizontal test. He said in class on Monday that when the upper limit is no longer, if changes between your, okay, so these are our boundaries. So that's why we have to take the horizontal, use the horizontal integrations. So we're gonna sum those areas. Write the equation. Area equals, in this case, it won't be upper and lower, it'll be left and right, or left and right, or can say positive and negative, high and low. You could say high minus low. Area between those boundaries, high and low. Is that high and low? No. Three, 1. High and low. Write our equation. High minus low again. So we have 3. Okay. Only have one function. Square root of x. Excuse me. The function is y equals, function is, okay. That's our function. We need to take it in respect to the y-axis. So we basically need to flip them, solve for x instead of y. So if you take the square root of both sides, times this by 2, times the exponent by 2, square of that side becomes y squared equals x. Because we're doing horizontally this time. So y squared is what goes in our equation. Y squared. And then the steps go back to the basics, where you take the antiderivative and then f of b minus f of a. So the antiderivative here is u equals y, n equals 2, n plus 1 equals 3, u over n plus 1 divided by n plus 1 equals y 3 over 3. Which is also 1 over 3y cubed. So you take the antiderivative of this, and that equals 1 over 3y cubed, upper limit, lower limit, upper limit, lower limit, there equals f of 3 minus f of 1. Plug the upper limit and lower limit into your function, the antiderivative function you got, which is 1 over 3. For this purpose, you're just plugging it into the function to get a value. So you can still plug in x for the y, because you just want to know what that value would be when you plug it in. X cubed graph it, find out what 3 plugged in would be. Wrong button. 3 equals 9, so f of 3 equals 9. F of 1 equals 1/3. So the area equals 9 minus 1 over 3, which is 8.67 units squared. Which is 8.9 minus 8.67 units squared. And that is the right answer. Right now, I'm going to go back over the example 2A because I think I made a mistake on that one. This is example 2A from the lecture notes. And then that's pretty much straightforward. Maybe one more. One more. Two more. This one I did already, but I think I made a mistake. So 2A from lecture notes. It says y equals 3 over x squared. Graph that. 3 over x squared. Graph. And you get something like that. Okay. You get something like that. I forgot to write this. Y equals x minus 3. X minus 3. And these are our boundaries. X equals 1 is a boundary, x equals 2 is a boundary. Graph that, I forgot to graph this one, x minus 3. Graph. And that comes in like this. Our boundaries, we're looking for the area bounded by 1 and 2. Somewhere in here. This is y equals x minus 3. Y equals 3 over x squared. Is this. That's a boundary. That's a boundary. That's a boundary. That's a boundary. Look for this. We're looking for this area. Our boundaries are vertical, so our integration areas can be vertical. Write the equation. Area equals summation of the upper limit or higher limit, which is 2. Lower limit, 1. Upper minus lower or high minus low. High minus low is the high. This is higher than this one in between those boundaries. So 3 over x squared, this is the function, high function minus low function, minus x minus 3. dx. I'm going to rewrite this to 3x to negative 2 minus x minus 3. I'm going to take the antiderivative of these. This is what I forgot to do last time, was bring that 3 back in. The antiderivative of x to the negative squared is n equals negative 2, n plus 1 equals negative 1. U x to the negative 1 over negative 1, which equals 1 over x. Negative 1 over x minus, so that'd be 3 times, that's a negative 1 over x. Bring down that constant that you took out. Minus, this is going to be 1/2 x squared, I think. Which is u. See, for this one, n equals 1, n plus 1 equals 2. So u equals x squared over 2 minus 3x. minus x squared over 2 minus 3x. Simplify. Negative 3 over x minus x squared minus divided by 2 minus 3x. I want to check this to make sure that's my antiderivative of this. So I'm going to take the derivative of this and see if it works out. Negative 3x to negative 1, which is 3x to negative 2. 3x to negative 2, and that's what that is, 3x over 2. So that's right. Upper limit, lower limit. Okay, what we did was write the equation, write the equation, upper minus lower, high minus low, high minus low. And take the antiderivative of the equation you wrote, and this is what we came up with. Let me erase this stuff so I have room. So we came up with negative 3 over x minus x squared over 2 minus 3x. F of b minus f of a equals the area, high minus low. And here you just plug this into the calculator. You just need to make sure you show them all the work that you can. So I have negative 3 divided by x minus parentheses x squared divided by 2 minus 3x. Graph it. And I'm trying to figure out the values of the upper limit minus the lower limit. High minus low. That's 9.5. This is I got a negative 6.5. Can't have a negative area. Let's see what I did wrong. Looking for an answer. I think he has this one worked out somewhere. He has this one worked out somewhere. Let's see what I did wrong. Let's try this again. Okay. Equation should be one and two, right? 2. Excuse me. This should be the right equation. Plug the upper limit in. This is okay. I drew the picture and I wrote the equation. In between the boundaries, this function is higher, this function is lower. High minus low. Antiderivative. No, I rewrote this as 3x to the negative 2. Took the antiderivative of everything. For this term, n equals negative 2, n plus 1 equals negative 1. U n plus 1 over n plus 1 gives you the antiderivative. Same thing for x, same thing for 3. All your terms, f of b minus f of a, upper limit, lower limit, high minus low. Value 2, I get 2.5 minus negative 0.5. What I get? 2.5 plus 0.5 equals 3. That's the right answer. 3 units squared. I think we got something like 1.6 something last time. And I think because we didn't add this, put this 3 back in. But that's all we have time for today. I hope I went over all the material well enough. areas by integration. Thank you for attending the SI session, and I'll see you next week. Thank you.